In this video, we're going to walk through the solution to a practice problem, looking at cobalt plus 3 ions and deciding if they're going to be paramagnetic or diamagnetic based on the ligands that are bonding to them in a coordinate covalent way. So let's start with the top. We have cobalt plus 3. Let's just write that down. Plus 3. And we've got a couple of different ligands. We have ammonium right here, and then NO2 minus right here. So these ones are going to be strong field ligands. Let's compare that to the next one where we have cobalt with hydroxide and with thiocyanate. So our thiocyanate is right here on our weak field ligand side, as well as our hydroxide. And so we have examples here of weak field ligands. Now, in both cases, I have a total of 6 ligands. So that means I'm looking at an octahedral compound. And that means that I'm going to have the same splitting pattern for both of these. I'm just going to focus on the d electrons here. So I'm going to have 2 higher energy and 2 lower energy. And so looking at my weak field ligand, I'm going to expect on this lower one, I'm going to expect a smaller crystal field splitting compared to the one above. So I'll have a larger one here. And I have the same metal ion for both of these. So I can kind of directly compare just based on the ligand's crystal field splitting strength. So for anything that's going to be larger, that means this is going to be a low spin complex. And for a smaller difference in our energy levels, we're going to have a high spin complex. So now I'm going to go through and just populate this with my different electrons. And my cobalt plus 3 is going to be a D6 element. And so I'm going to have 6 valence or d electrons to add into these. So starting with my low spin complex, I'm going to populate one in each of the lower level. And then because I have a large gap in energy, it's going to be actually more favorable to pair these electrons than add one to the higher energy level. So 4, 5, and 6. Now looking, so here I have my low spin complex, and looking at it, I have no unpaired electrons whatsoever. So this is going to be diamagnetic. Now looking at an example where I have weak field ligands and expect a smaller crystal field splitting, I'm going to assume a high spin complex. And so I'm going to populate my 3 on the bottom. And now I'm going to populate my higher energy orbitals first before I pair up. So now I have 4 unpaired electrons. I have a paramagnetic compound.